Hellcat.
Physics is all about how things move and why things move. There are a lot of things happening in this world. Objects move, fall, rest, each and every second. But do you know that the motions of all these things can be predicted? For example, take a basketball. And now I can predict the motion of the basketball if I know all the forces acting upon it, including the drag given by the air and the frictional forces too. And if I know all these forces, then I can accurately predict whether the ball thrown by the player will go through the basket or not. And today, we are going to talk about something really interesting. We are going to talk about something really fascinating. We are going to talk about the theory which literally shook the whole world and changed everyone's perspective of seeing the universe, which changed everyone's perspective of seeing the world. And the theory which we are talking about is none other than the theory of relativity, proposed in 1905 by the father of science, Albert Einstein.
And every theory proposed by Einstein is based upon his imagination.
Einstein believed that imagination is more important than knowledge. Imagination is more powerful than knowledge. So on the basis of his imagination, he was able to change and remake the history. He was able to change the history of science and remake it. And also on the basis of his imagination, he dared to go against, he opposed the greatest scientists of that time, Sir Isaac Newton and Galileo Galilei, and told that space and time are not absolute. We will get to this later on. Now, let's talk about relativity. Okay, let's say relativity can be divided into two types, general relativity and special relativity. You ever thought that why does all the planets keep on revolving around the sun? And why all the planets are held on the imaginary path which we know as their orbits? Why all the planets are held on their orbits? The answer seems to be simple, right? Because of sun's gravity. Because the sun's gravity is attracting all of them. But if the sun's gravity is so much powerful that the huge bodies like Jupiter and Saturn are held on their orbits, then why don't all the planets and all the moons and all the asteroids go and collide with the sun?
Confused? Don't worry. Stick with me, because the answer is hidden inside general relativity.
Before 1905, we used to believe that the space is flat like this one. But after 1905 or after the publication of general relativity, we believed that we knew that the space is not actually flat like this one, but is curved like one in this picture. Yes, the space is curved like this one. And you might have seen this picture somewhere on the web or in different books. And this one, this picture or this phenomenon, let's say it's a phenomenon, this phenomenon is known as the curvature of space-time. In the general relativity, Einstein proposed that the space is curved like this one in this picture. And he told that every object in the space, including a small asteroid to the great stars like Polaris, each and every object or each and every body having mass in the space creates this curvature. And we can simply understand this curvature as the gravitational field created by the body having mass. Yes, it is the gravitational field created by every body having mass. And the impact or the effect of this curvature remains the highest at its center. And it goes on decreasing as you go away from the center. Let me explain it to you with an example. Take the Mercury, the smallest planet of the solar system, and the planet which is nearest to the sun. Now the Mercury takes only about 80 odd days to revolve once around the sun. Now see the see the Mars, the fourth planet of the solar system. The Mars takes about 700 odd days to revolve the sun once. This proves that the impact, the effect goes on decreasing as you go away from the center, as you go away from the center of curvature. And all the planets do not go and collide with the sun, because all the planets have their own gravitational field and own magnetic field which repels, which resists the force of the sun. And if any planet wanted to get out of their orbits and stop revolving the sun, then they will have to gain the velocity of 3,000,000 meters per second, or simply 3 crores or 30 million meters per second, which is equivalent to the velocity of light. And the moon revolves around the earth because the earth also creates the curvature same like that of the sun, which makes the moon rotate or the revolve around the earth. And the moon does not come and collide with the earth because the moon also has its own gravitational field and own magnetic field which resists the force of the earth.
Einstein explained the motion
not only of sun or the earth. He explained the motion of many other stars, many other planets and many other moons. But generally, Sir Isaac Newton is credited for studying about the motion of heavenly bodies of this space. But Newton was trying to know about the motion of three bodies moving in orbit, like the sun, earth and moon. He was trying to study about the motion of this kind of object which revolve around a certain point and keeps on revolving on their orbits all the time. He was trying to know about this kind of motion, but it was something which made Newton say that he was unable to find out about this kind of motion because the formulas of Newtonian dynamics, like the F is equal to ma, which is force is equal to mass times acceleration, and the law of universal gravitation, which is g times m1 m2 divided by d2, was unapplicable in this kind of circumstances. Einstein came up with this formula in the general relativity, and this formula made it a lot more easier to study about the heavenly bodies, and it was accurate because the solar eclipse of 29th May 1919 is known as the proof for general relativity, and it proves that the general relativity and this formula is 100% accurate because the prediction of the eclipse was done with the help of this formula, and later on the eclipse occurred and it proved that the formula and the general relativity is absolutely accurate.
Still, lots of predictions are done with the help of this formula.
And still, the theory of general relativity and this formula are still in use in so many fields, and it was all about general relativity. Now, what if I say you that for you and for me, time can be different, and it's not like you are at one part of globe and I am at another part of globe, so that when there is night at a place, I have day at my place. That's not what I mean. That's not my point. Let me make the point clear to you. What if I say you that the two events which has occurred at the same time can be seen at different interval of time by the two of us? Just imagine that you are sitting on a train which is moving at half of the speed of light, and I am just sitting on the bench just besides the moving train, and the bench is not moving. Now imagine that two thunders strike at the same time, and let's say that the distance between the two strikes was around 100 meters. And now, would you believe me if I told you that I will see the two thunders striking at the same time? It's obvious because the two have struck at the same time, right? But what if I say you that you will not see them striking at the same time? You will see that the thunder which is at the right side, you will see that it has struck first, and the one on the left side, you will see that it has struck later than that of the first one. I don't think you would believe me if I said you this. Nor anyone did when Einstein first proposed this as his special relativity. And there is a huge mathematics behind this. He has explained it with a huge mathematics, but we can simply understand it as it is practical, because you are moving at the speed of light and you are moving towards one and away from the one. So because you are moving at the speed of light, you can see every precise movement of the light because you are moving at the half of the speed of light. But I can't see them because I am not moving at the speed of light. I am just still in a place, and you can see that because you are moving at the speed of light, so that you can see every precise detail, even there is a difference of millisecond in the striking, but you can observe that because you are moving at the speed of light, but I am not moving, so that I can't get the detailed information of the striking. So this was the reason why you will see the one faster than the another. This was the imagination of Albert Einstein, and this is known to be one of the most famous thought experiments in the world. And later on, Einstein derived all these things theoretically proved. And this is not a small thing, because this theory, this law of special relativity, can be used for teleportation and time travel too. Now, we all know that light is a wave, right? But Einstein told that light is a wave, but it is also a particle, because light can travel through space where there is nothing like a medium, right? But no wave can travel through space. Now, it leads us to that there must be something like medium in the space, or the light should not be wave. So Einstein told that in some circumstances light behaves as a wave, and in some circumstances light behaves as a particle. Confusing, right? So let's leave it there now, because I'm thinking of making a separate video on this thing. You will find lots of mind-boggling things similar to this in the special relativity, and all the things I told you till now, they are just a small part of this. But now we are going to talk about one of the most important term of the special relativity, weightlessness. You can predict its meaning from the word itself, right? Weightlessness. It's like not feeling your own weight. You all might have played swing at least once in your life, and if you had, you might have felt some strange feeling on your gut when you move down of the swing, right? That's not exactly weightlessness, but it somehow is. And honestly, weightlessness, a complete or accurate weightlessness, a true weightlessness, is not possible on the earth. Because according to the Newton's third law of motion, for every action there is an equal but opposite reaction. So every freely falling body on the earth has to face the drag of the earth and the frictional force too. So it is not possible on the earth to have an accurate, to have a true weightlessness. But Einstein thought in a different way. Einstein thought that he was moving in a vacuum in an elevator. He thought that he was falling in a vacuum at very high speed, faster than the speed of light. And he thought that at that time he should not feel his own weight when he is falling in a vacuum at very high speed. And that was something that exactly happened according to his imagination. But it was not possible to create such a huge vacuum and demonstrate his special relativity and weightlessness. But he demonstrated it in a different way. And now I am going to demonstrate you special relativity and prove that the weightlessness of special relativity is not fake. It's true. It's 100% accurate. So let's go. Demonstrating special relativity and weightlessness, you need a bottle, and then makes holes in the bottle so that the water will spill through it like this. Okay, then drop it like this. Did you see that? After I dropped the bottle, after I lift the bottle, the water stopped spilling out of it. Now before explaining you the reason, I want to ask you something. What is weight? What do you mean by weight? Okay, simply weight is something because of what you are getting pulled towards the surface of the planet, right? Because of weight, gravity is acting upon you. And now what does weightlessness mean? Okay, weightlessness simply means not feeling your own weight. Now we can say that gravity acts upon you only if you have weight. And if a body is not feeling its own weight, then the gravity will also not act upon it. So it was the same reason why the water didn't spill out of the bottle. Because the water was not feeling its own weight. And if it is not feeling its own weight, then gravity will also not act upon it. So the water didn't spill out of the bottle. So it was all about special relativity. All the things I told you in the video, all the things I explained you in this video, they are just a small part of general relativity and special relativity. They are just some basic parts of it. And besides the general and special relativity are great, Einstein didn't win a Nobel Prize for it. Einstein won a Nobel Prize, but he won it for the photoelectric effect. And besides, Einstein is known to have such a brilliant mind. Besides, he is known to have the most intelligent mind in the world. He was unable to solve the problem. He was unable to solve the mystery of quantum mechanics. He was trying to connect quantum mechanics with gravity and form a new theory which is named as quantum gravity. But he was unable to solve its problem, and still quantum gravity is one of the most complicated problems of science. Einstein should be a source of inspiration for everyone. He should be an inspiration for everyone because he didn't go to a reputed school. He didn't go to a reputed college, and he was a school and college dropout. But still, today he is known to be the greatest scientist of the history of science. So it was all about today's video. If you liked the content of my video, please like the video, and if you haven't subscribed my channel yet, please subscribe it, and don't forget to share this video with your friends because they will find it mind-boggling too, and let them get fascinated with this video. And if you haven't watched my previous video, I have dropped the link in the description. You can just click on the link and go to watch my previous videos. And if you have any suggestions you want to give to me, you can just write it below in the comment section. And if you want me to make video in any topic, you can just write the topic below, and I will be back with same kind of video. Till then, stay home, stay safe, and of course, stay curious.